you very much. Hi, everybody. So today I'm going to talk to you about Naxsi, which is a web application firewall for NGINX. So first, a few words about me. So I've been doing penetration testing since 2003, and I started to get a strong interest into defensive security since only a few years back, simply because it felt boring with time to always break through the same doors. And the other reason is that my company started doing hosting, and we're facing strong issues because we are doing hosting, but for third parties, so we do not have any grip on the developers. So even if I assume it's common knowledge, most people here are quite aware of the issues. The thing is that web applications, there's always a lot of customization, so it's a lot harder to have standard responses to any security issues. Especially here, so we are doing hosting, so we do not have any grip on the developers and the quality of the code, and most of them are like e-commerce websites, so with a lot of customization and very specific things. So it's just like you're a mechanic guy and you are asked to handle only tuned tuning cars with a lot of fancy options, but not always very safe ideas. So in a perfect world, we wouldn't have to have web application firewall because we can address the issue at the very beginning, which is either by educating the developers or make them fix their own issues. However, here we are really talking about handling third parties' problem. Like, okay, they have issues they get on a frequent basis, and they say, I hand it over to you, and then I don't want to hear about it anymore, and you need to solve it for them. So the fallback was web application firewall. When I started the project in 2011, it was not in the state it is right now. So because, for example, mod security was not yet ported to NGINX, there's no real solution for NGINX. Plus, I'm not a really strong believer in the big signatures approach when it comes to web application security. Because, for example, when you see talks like the one given by people from Portugal yesterday, you can see that browsers have behaviors that can change and they will not stick to the RFC, so it will become more and more difficult to have with a single regular expression detect a cross-site scripting or an SQL injection, especially with very versatile language such as JavaScript and the evolutions that are reading by HTML5. And so for the open source web application firewall, so mostly mod security, and when it comes to proprietary web application firewalls, first of all, our first result was the quality is very uneven, and it's not because it has a higher price tag that the quality is better, and it's very hard to get feedback or integration. Plus, the costs might be very difficult to handle, especially for a small company, because we're not a very big company, so we have limited financial possibilities, but still a few thousand websites to handle. So that's why we started to develop Naxsi. So Naxsi, the idea is that instead of relying on very complex signatures like a big regular expression aiming to detect most of the cross-site scripting or SQL injection, it will rather focus on detecting the very small parts. Like it will focus on simple quotes, double quotes, equals. Actually, most of the characters that we can see in use very frequently in attacks. And whenever these tokens are detected, they will lead to a score increase that will itself lead to an action. So it allows us to have a very small set of rules, of basic rules that are shipped in the default configuration, and it will still be able to detect most of the attacks, and it's especially resilient against very obfuscated attacks. Like, for example, if you look at the challenge that were organized back a few years by mod security in order to find bypasses in the SQL injection detection or cross-site scripting, most of the time you will end up with very complex actually payloads that will aim at either using browser specificities in order to have invalid HTML but that is still interpreted by the browser, or very obfuscated patterns. And in the case of Naxsi, as it will focus on these small characters, it will lead to a very strong score increase. The fact to have such a simple approach has the advantage to have a very quite small actually code base because it's less than 4,000 lines of C code, and it comes along with tools in Python that are used mostly for reporting and whitelist generation. And since now only a few months, we already also integrated lib injection. So I don't know if you know lib injection. It's developed by a company called Plan9, I think. And it relies on tokenization in order to detect at least SQL injection and now as well cross-site scripting. The approach of the tokenization is a bit like a more evolved approach at what Naxsi attempts to do by spotting the characters that are used in common attacks. So, as Naxsi doesn't rely on complex signatures, the downside will be that you need to focus a lot more onto learning because you can have very easily false positives. For example, as soon as you will have fields that are very open for the user to interact with, if it's even common text, it can lead to some false positive if they need to use simple quotes or double quotes. So the global workflow is that, so Naxsi is a model for NGINX. It will produce logs. These logs can then be transformed and injected into an Elasticsearch database. So Elasticsearch database for us has two advantages. First one is that in terms of visualization, because as I'm very, very bad at HTML and things like this, we tried in the past to have our own console, but it was quite a failure. So actually using, for example, soft such as Kibana, you can produce awesome dashboards with absolute zero knowledge as long as your data is formatted in a correct way. So the logs are injected into Elasticsearch, first for visualization, and then there's a tool called NX API or NX tool that has two goals. First, it will allow you to generate the whitelist, because when you will put your site in production at the beginning, as Naxsi is very dumb and doesn't rely on complex signatures, for example, even in the cookies, it might trigger a lot of false positive if you use Google Analytics because, there's a lot of weird characters, so it will raise you alerts. And then this tool, relying on the data that is into the Elasticsearch, will generate whitelist for you that you can later set up in production. And so you run into a cycle like this, and as soon as you see that the exceptions that are reported by the web application firewall are not false positives, it means that the learning is over. So this is for the global workflow. So in this approach, the main weakness is the need for learning because it's very prone to false positive. And if you're on applications that evolve in a very fast way, I mean, strong evolution, not just adding a few pages, but changing the way the user can interact with the application, then it requires some coordination because else, when there's a new version that is deployed, you might break things. And if you are not in learning, you might block legitimate users. And it has no intelligence, which means it's unsuitable for some specific case. Because, for example, a few months ago, there was a vulnerability on an e-commerce solution called Hybris, which has a great idea to send data legitimately in base 64, like for paths to images. Naxsi has no intelligence. He has a very limited decoding abilities. So in some specific case like this, it's a corner case for him. It's very difficult to manage. On the other hand, it has a very good resilience against unknown and unobfuscated attacks. Since the project started, we never had to modify the core rule set because of a new exploit or of a new vulnerability that appeared. The simple approach has this advantage. And it has very good performances. I will talk a bit about this later, but it has a very, very low memory footprint as well as CPU usage. And it was one of the challenges we had since the beginning in the conception. Plus, as long as application didn't evolve, you never have to update rule sets or update new signatures because it has no signatures. So once it's set up, you can let it run for years and years without having to touch it, as long as you didn't change radically the application. And the learning process is now very strongly, you are strongly assisted in the process because at the beginning it was something extremely troublesome and now it's getting better and better. So in terms of what it's able to parse, it is able to parse classical things, JSON and various kind of posts, which are form URL encoded and multi-part and form data. So this is what the various piece of a Naxi configuration looks like. So the first one, for example, it's a detection rule. So it will be every time composed of a string or a regular expression, which is what you want to match into the HTTP traffic, and what is called a match zone, which is where do you want to match potentially this pattern. Then you have score, which means that if the pattern is detected in one of the zones, then the score will increase, for example, here, SQL by 4 or XSS by 8, plus an ID that is using for whitelists. So regarding what we call match zone, it's simply a way to cut the HTTP request into various parts, which are the URL, the arguments that are given in GET after the end of the URL, the HTTP headers, the body, or file extensions in the case of file uploads. Then you have the check rules. That means that once the request is processed, the request will reach a specific score, and then you will say if the request will reach or get higher than an SQL score of 8, then you can decide to either log the request, block it, or drop it. The difference between a block and drop is that as there is an important learning process, while you are in learning, you still want to be able to drop some specific malevolent requests. So that's why drop is for, but I will come back on this later. And then finally, you have the whitelists that are generated by the tools. Like, for example, here we are saying that we want to allow a specific pattern to be present in the HTTP headers named cookie, but only for the URI /x. So the learning process is the most troublesome part of not having complex signatures. So it's relying on the logs that are inserted into Elasticsearch, and then there's a tool that helps the user to create a whitelist. So there's several approaches. A lot of applications are quite standardized. For example, if you take common frameworks or solutions, so you can create templates. For example, there are some people in the community that will maintain whitelist templates for Naxi, for WordPress or Drupal, so that people don't have to do learning on their own and they can use it, the ones that are produced by the community. However, as soon as you get into custom applications, you need to create your own ones. And then we can do it simply based on the statistics. It means that, for example, if 80% of my users are all triggering the same event in the same page, it probably means that it's a false positive, and then I want to whitelist it. And this is what the tool is here for, is spotting the very common patterns, and then say, okay, this is a false positive, we want to whitelist it, and it will generate the whitelist for the user with giving him some indications on why the tool thinks it's a false positive. And then once you generated your whitelist, you can then tag the events into the database to say, okay, all these events were false positive, we tag them. So you get an increased visibility on the current learning state of your web application firewall. So Naxi relies on two main modes, which are the learning phase, which is at the very beginning, and the blocking phase. So during the learning phase, all the HTTP requests are analyzed, but nothing is blocked. Naxi will simply log everything it sees and every anomaly it sees for further analysis. And once you are satisfied with your learning, Naxi can be set to blocking mode, where every request that match an ID that was not predicted or allowed will get blocked. However, there's a tweak, because when we are doing learning, especially if you are doing learning on websites that are directly exposed to on the internet with no trusted traffic source, then you still want to be able to protect your site from attacks during this learning phase. And especially if you have, for example, a site with very, very low traffic, you might get more noise from bots and people attempting to break in than from legitimate users. It might be true for people that have small personal websites. So when you are in learning mode, you can still drop some specific requests, relying on some third-party tools, for example, lib injection or some blacklists that are produced by another company. But I will speak about this a bit later. So for the learning mode, when it comes to market applications, so for example WordPress, or actually most of the framework or the common framework, you can see pattern on the way, for example, the forms will work, because the hardest part with learning, for example, is when you have websites with very strong user interaction, like for example forums or contact forms and so on. However, they all behave more or less in the same way, so you can predict what are the idea are going to match. For example, when you are using WordPress, a lot of the form fields will use brackets within the variable names, which is something for Naxsi it's abnormal, so it wants to block it. However, you can create templates that will predict this and ease the process of learning. And when it comes to homemade application, you have several options. So either you rely on statistics, but it's only viable if you have traffic that is high enough, so that the noise provoked by bots or automated exploit items are low enough so that they won't pollute the learning process. And for the last case, you can always rely on trusted traffic sources. For example, if you have the chance to be able to do the learning during QA or staging phases where you know that most of your traffic can be trusted. And so even when it comes to non-market applications, the learning tool will rely on what is called templates. It's as a learning tool, his sole job is to query Elasticsearch and asking globally for what is the most common exception that was triggered by the most users, because this is probably a false positive, so it's simply Elasticsearch queries. And the templates are Elasticsearch queries that are optimized because we know it's things that will happen often. For example, Google Analytics in the cookies, it will always behave in the same way. So you can have predefined templates that if you used to use Google Analytics, they will match immediately and suggest you the right whitelists. So, for example, this is an example of a template and whitelist. So at the bottom, you can see, for example, this is a template for Magento, which is an e-commerce solution. So simply here, we want to allow open and closing brackets in the variable names for specific forms, because all the Magento instance will have the same behavior. So you can predict this and directly have the right whitelist. And on the top here, it's the different approach. It will attempt to detect whether or not a Magento is present, because it says if a Magento is present, then we will very probably see opening and closing brackets in variable names in post on this specific page. And as soon as some part of the templates match, you know that it's a Magento application, and then you can apply the rest of the template, because you know all the Magento will have this and this and this specific behavior that you can predict and earn a lot of time for learning. For us, this is especially useful because we have several thousand websites, but we do not have grip with developers or things like this. So we get new sites, and the idea is to detect as fast as possible whether it's a standard application, if it's something that is completely homegrown, or if it's a mix of several applications, like for example, e-commerce website with a WordPress and some custom parts. So the idea is to be able to reduce the learning process. So here an example of how the learning tools behave. So so far it's a simple Python tool in command line. So it will query directly the Elasticsearch database. Like here, for example, I'm querying the database for a specific website that is currently in learning. So first of all, it will tell me the whitelisting ratio that has already been done. Means that amongst all the events here, like 85,000 events, only 70% of them have been tagged as whitelisted and as false positive. And then it will as well tell you the top URIs on which you will see the most frequent exception happens. So you can, in this way, you can progress into learning. First, you will try to do the learning on the parts that will trigger the most false positive. Because, for example, if you take a brand new site with no specific rule set, at the beginning, even the cookies will match, will trigger false positive. So which means every user on every page in every request will generate an event. And as soon as you did, for example, learning for the cookies, the exception rate will drastically drop. And you can apply the same thing on the URIs. Because here, for example, probably it's the reason it's matching so much here, it's because it's a formula form where people can update their profile, so input a lot of uncommon things, especially if they can update their password, which will trigger false positives because they will see uncommon characters in the password. So it will do this first level of reporting to help the user perform his whitelist. And then there's the headers, because the zones, so either the headers or the URIs or the body, in which the most exceptions were seen. So here, for example, we can see that it's still a very fresh sheet because a lot of events still happen in the headers, specifically in the cookie, which means that nothing has been done. And for example, here, as soon if we solve the main form and the headers in terms of learning, the application, the exception rate will drop so drastically, maybe then only a few more days of learning, and the application will be ready to go into blocking mode. So first, it helps you to know in which direction you need to work for generating whitelist, and then it will actually help you to generate whitelist. Like, for example, we are still on the same example with open and closing brackets in the names of the variables. Here it will say, it thinks that it is indeed a false positive. Why? Because there's 345 different unique peers that trigger the same exception, and which represent 70% of all the users. So if nearly 20% and several hundred of users are all triggering the same events, you can be pretty sure it's a false positive, or you're under quite a consistent attack. And then as well, it will provide you some extra information, like, for example, a sample of content that triggered the event. So the idea is that Naxsi, when it's in learning mode, allows you to log as well the content of the variable that triggers. So it allows you to then process it with third-party tools, either lib injection or other web application firewall, to decrease the false positive rate. Like, you get a lot of events, and then you will use another firewall as well, or third-party tools to detect whether it's spam or it's legitimate content, and then you can reduce the volume on exception and do the learning only on the refined data set. And so the idea is here, so NX tool comes with a lot of templates and generic templates. So you can either say, okay, I know it's a Magento, so please generate me only the whitelist for Magento, or here I'm like using the full auto mode, which will attend all of the templates and all of the possible whitelist, and only provide you the ones that matched high enough volume of traffic to be considered as legitimate. And internally, in order to do so, it relies on scoring system. So like, for example, if less than 10% of my legitimate users triggered an exception, that I'm less inclined to consider as a false positive, because 10% is not much. But on the other hand, if more than 20% of the people will generate this event, then it's probably a false positive. So this is how it works, and trying to help the user with rating systems. So this is typically an example of an event that is put by Naxsi into Elasticsearch. So we'll have in which zone did the exception happen, the peer IP of the people emitting the request that contained some unusual content, the fact that it was already or not tagged as a whitelist, the URI on which the event happens, and then the comments. Comments will be used either to say at when the event was imported into the database, so we can have time tracking, or when was it whitelisted, so we can know, okay, at yesterday at 6 p.m. we decided to whitelist all this, so now it shouldn't be an issue anymore. Then it will provide as well the server, which is a full FQDN of the server, and the content. If enabled, it will provide you a sample of the data that actually triggered. Like, for example, you have a rule that will match on open closing brackets. It will say, I match it on open closing brackets, and here's an example of a user that actually triggers in content, and it will put the content directly into Elasticsearch, so the human, when doing the whitelist process, can review things and see, okay, it looks legitimate or it doesn't look legitimate. And here's the variable name. As well, it will include the coordinates and the originating country, because I'm working in a French company, and a lot of our customers are very French-centric people. So when we are doing learning, we can ask the learning tool to consider with a higher priority events that are coming from French IPs. Because, for example, when you have website in French, there's a lot less chance that the event you will see coming from China or Russia are legitimate. So it will allow you to reduce a lot the scope, especially as there is a lot of internet noise and bots coming often trying to scan things. So it will allow you to reduce this. Or for example, you can when you are doing your learning, you can specifically exclude some countries. And as well, it's cool for having awesome dashboards with the little maps and the little dots. But it's morely for management because they like this kind of things. And so the dates at which the event happened and the idea of the event. The idea is that, for example, a user that is sending a request with a lot of, for example, if we take a real XSS cross-site scripting sample that is sent, actually it will match multiple rules like opening brackets, the quotes, simple quotes, double quotes, dash, etc. So it means that for Naxsi, one request will generate maybe 10 or 20 events if it has a lot of weird characters. And these events are treated individually, which means like on the dashboard, if there's one false positive, usually there's only like, for example, 1 or 2 characters that will match, but a real payload will generate 10 matches. So it will represent a higher volume of data, which is useful when you are doing visualization of data because you can see users that will trigger how to explain? That will trigger a lot of different events within one request. You can be pretty sure it's not a legitimate request, but indeed an attack. Or else the guy has a very weird name with a lot of quotes and brackets in his name, but it's not going to happen much. And so this is an example of a Kibana dashboard. So this one is a simple one. However, I'm not sure you can see with the colors. So you have like graphs of all the websites and the level of events. And for example, even if you are only using learning mode, because we know some people in the community, they don't want to do the learning process because they think it's too troublesome, or they do have applications that are moving too fast. But only in terms of visualization of level of attacks, it can be extremely useful, because if there's someone scanning or attempting an attack on your website, you will clearly see a huge raise. And here, for example, we have, as you can see, maybe, 20 websites that are in the top 20. And so you can immediately see, okay, this website is being specifically targeted by a scan or something like that right now. So it's quite useful for the monitoring teams. So as well, with Kibana, you can put the little world map if you want to show off to people, but it's not very useful for real. But still an awesome feature. As you can see, learning can be quite troublesome. However, NGINX being an awesome software, you can do a lot of cool tricks to make the process very simpler. A lot of the behavior of Naxsi can be controlled by variables that can be set within NGINX scripting. Like, for example, we are setting up a new site. The websites need to be in production, and we know the website has some vulnerability on some specific page. You can say, okay, I'm going to enable Naxsi just for this specific page, or I'm going to turn on learning for everyone except this IP, or for everyone except people from this country. So it's a kind of a Swiss knife. It means it has a very simple functionalities. However, you can easily interact with it using NGINX scripting. Plus, I don't know if you are familiar with NGINX, but NGINX works with a principle of location, which point to different part of a website. And for example, one thing you don't want to do is to try to do learning on a back office of a very complex CMS, because people will tap HTML and so on in the backend, and it will soon become a nightmare for you. So you can definitely exclude this kind of parts of the web application for all very simply. So here, for example, I'm saying people coming from a very specific address, I will disable learning and I will turn on the lib injection engine. But as well, for example, if there's tomorrow a vulnerability that appears on a WordPress or SQL injection on a specific WordPress plugin, you can say, for this specific URL or this URL matching this regular expression, I'm going to enable lib injection and I'm going to turn off learning. So it means that every SQL attempt will be dropped, but only for this URL or this parameter, which is quite convenient when you need to do some quick and dirty patching or react very quickly facing vulnerabilities. So using this kind of variable, so you can turn Naxi on off, turn learning on off. So there's also something quite useful which is called post action. So it's specific to NGINX. Post action is a directive that says once you finish processing the request, please send the user to this specific location. And for example, in Naxi, we are using it for when you are dropping someone, you decide that the request is illegal. Instead of just returning specific error code, you can first giving an error code and then redirect him to another page where he asked to enter a CAPTCHA in order to validate eventual false positive. So which is something quite convenient, even if some people might think it's intrusive. If you are doing like internal learning, it's extremely convenient. And you can as well turn on and off lib injection, both for SQL or XSS. So as I was saying, so there's two external things. So the original idea of Naxi, or actually my original idea was that signatures are bad and regular expression are even worse. However, some people disagree with me, and especially people doing share hosting, because we have the chance to have only like quite big customers, so we can spend some time working on each individual website. However, for example, there's a German company called Mars System, which is doing a lot of mutual or shared hosting, and they are keeping up doxy rules, which are simply a set of blacklists based on the emerging threat system. So they are doing blacklist for Naxi, generating blacklist rules, and it comes along with a cool client that allows automatic update with a dashboard. With a dashboard, because they can do HTML and things like this. So it's quite useful, even if you are doing mutual hosting or anything, to have this, so just you can have a visualization. And that it's emerging threat, it has a very, very low false positive rates, and he's very cautious about this. So it comes handy, and for example, we use it during the learning phase in order to be able to fend off the most obvious attacks. And as well, lib injection is a good complement to Naxi. So, sorry, I just speak about this. So, feedback from real life. The approach is might seem extremely trivial, however, it works quite well. We challenge it quite a lot, and especially it stays very simple to manage. So you don't have to. You don't need a PhD in PCRE to be able to maintain the whitelist or the rules, which is something convenient. And it's not hungry at all. It's very simple. It's very cheap in terms of resources, both memory and CPU. However, some specific cases, as I speak earlier, like for example, legitimate content in base 64 is not something easy to handle because it does very limited decoding. For example, mod security is able to handle this kind of case. Naxi, for him, it's quite complicated. You need to predict the various possible encoded patterns in base 64 to output several rules, so it's not optimized at all. So a few achievements. So it has been used at least to protect one very, very big website that handled a few terabytes of traffic during peak season. And for us, we use it on more than 2 GB incoming traffic, as we are doing a lot of e-commerce during sales. It's a very good example to see how well does it scale during sudden traffic spike. And it has been audited quite a lot and challenged. So if anyone of you happen to either find cool things or want to set up CTF and bug bounties, we're always open to help with bug bounties on Naxi or provide some kind of support. So thank you for your attention, and if you have any questions. Yes?
Is it correct that you are only checking for those simple characters?
Oh, so actually, for example, is it only checking for simple characters? No, not only. It's mostly checking for simple characters, but as well it might use some keywords, like for example for SQL injection, but not for JavaScript at all. It has like no keywords for HTML or JavaScript because we think it's too versatile and can be manipulated too easily. However, it uses some keyword for SQL because if you want to avoid using keywords, and you will have to use weird characters in order to bypass eventual regular expressions.
And
You don't agree? Mm-hmm. More specifically, what are you thinking about? Mm-hmm. Mm-hmm. Yes. Yeah, actually, it's. I mean, any request that will either have anomalies in terms of the ways request is construct, or any of the internal rules will match. But I'm not sure to. I don't know specifically which case you are thinking about. So. Okay. Yeah. Hmm. Yes, it will. But however, if I mean, I always encourage people. We try to set up a lot of changes with some bug bounties in order to push people to find bypass, because I do think that web application firewalls are not silver bullet at all. So I'm always encouraging people to try to find some new stuff. So if you happen to have ideas, please don't hesitate to try, or at least suggest the idea. Any more questions? Sorry. It's on GitHub. Oh, sorry, it was on the first slide. I forgot to mention. So it's open source. It's on GitHub, and it's GPL. Here. You can fetch it on GitHub. Actually, it's as well present in quite a number of distributions. It was present in Debian until I think the next one they are dropping it. But it's present in most BSD package. You can fetch it directly from the official repositories. Yes?
Maybe I didn't get it quite well, but it seemed like your whitelisting works against the Elasticsearch logs.
Mm-hmm.
So I guess you don't log everything. Like there's a certain, like the data, like you don't log all the packets. So how can you whitelist like a more complicated field? Not like URI or any TCP header.
Oh, so actually, so it's in the Elasticsearch. What we will log is that so every kind of violation, and we will put as well a sample of the data, but not the whole request inside. So the idea is for example, if a new parameter appears on an URI, for us it's not an issue, except if this parameter is either constructed in a weird way or contains some uncommon data, then it will be logged. So it doesn't log all the traffic, but only all the traffic that it thinks that is uncommon or might be an attack.
All right, and I have a second question.
Mm-hmm.
What amount does it really depend on NGINX, or if you have like future thoughts about other platforms?
No other thoughts about other platforms. Actually, the reason I developed Naxsi is because we are using NGINX a lot, and I really like NGINX's approach, so I'm not planning to port it on Apache or things like this. Yes? Oh.
I would like to know how you are deploying Naxi. Are you deploying it compiling the source code together with NGINX like you do with other modules? Or are you using NGINX with your modules like the reverse proxy?
We are using NGINX with our module as reverse proxies.
Okay, and what about HTTPS?
Actually, for us, it's a reverse proxy that will offload the certificate, so we can still.
The certificates you have from the traffic.
Mm-hmm. Yes,
Okay.
it's both HTTP or HTTPS.
Okay.
Any, yes?
You may have talked about it
Yes.
So you actually like inspect JSON
Yes, JSON, yes.
and the same for WebSockets?
No, so the question was about JSON and WebSockets. So JSON, yes, because it's something we face. WebSockets, not yet. We started to think about it, but I think it will require a more evolved approach in order to give consistent results. Any more questions? So thank you very much.